Hello to everyone and thank you for joining us today. My name is Marius and I'd like to welcome you to today's Oracle Advisor webcast titled Understanding and Troubleshooting Ora 600 3020. Our speakers today are Ioana Cristina Oprisha and Ana Maria Vlășceanu, who are technical support engineers. We also have Angela Ștefănică, Cristina Mogos, and Silvio Martinez joining us as panelists for the Q&A session. We expect today's webcast to last approximately 60 minutes, including a brief Q&A session. This session is being recorded, and at the end of the session, I will go over when and how you can access the recording and the question and answer from the webcast today. Questions can be submitted through me throughout the presentation via the chat or Q&A panel. Your questions will be collected and read aloud during the Q&A portion of the call in the order they are received. To aid in question collection, please only submit your questions once. If you are listening via voice streaming and lose sound, go to Communicate Audio Broadcast to restart the audio streaming. Should you still encounter difficulties, please dial into Intercall directly using the numbers provided in your reminder emails. Any questions that remain unanswered at the end of the session will be transferred to the community where you can continue the conversation. What you see on the screen now is a reminder that this advisor webcast is intended for information purposes only. Any features or functionality described for Oracle's products remain to the sole discretion of Oracle. Now, let's get started with our presentation. Cristina, if you are ready, I'll hand over the webcast to you.
Thank you, Marius. Hello, everybody. I am Cristina, and together with Ana Maria, we will play the role of presenter today. The main reason for which this webcast was created is that many service requests are logged related with this error. After today's webcast, we will have a better understanding of corruption caused by lost rights detected with errors Ora 600 3020, Ora 752, Ora 753, Ora 756, possible causes of those errors, how to troubleshoot the errors when they occur in a data guard environment or when performing a restore recover from a backup, and how to enable early detection of lost rights. During this session, we will discuss the following topics: meaning of the stack recovery error, understanding lost rights, detecting where the lost right has occurred, what actions should be performed when the errors are reported, and best practices. According to the errors note, this error is called a stack recovery. There is an inconsistency between the information stored in the redo logs and the information stored in the database block being recovered. Most of the times, this error is encountered in the data guard configuration because this internal error is reported when there is a process involved that applies the redo. Stack recovery can occur when a lost write was detected to have been performed by underlying operating system or storage system of the primary or of the standby database during normal operation. The error format contains the following information: absolute file number of a data file, block number, and data block address. What are the causes of Ora 600 3020? This error is an indication that a lost write was detected. The lost write can be on the database that generated the redo, on the database that applies the redo, or even the redo chain can be broken, missing a change. There are also several defects that can cause this error. A complete list of bugs for each database version can be found in the errors note, Ora 600 3020, stack recovery, document ID 3866.1. What is a lost write? All Oracle documentation state a data block lost write occurs when an I/O subsystem acknowledges the completion of a block write, while in fact the write did not occur in the persistent storage. The result is that the block in the database is a stale copy, which is not logical nor physical corrupt because block internal structures are correct. Due to this reason, nor RMAN nor DBVerify are able to detect inconsistencies caused by lost writes because they perform intra-block corruption checks. During the recovery process and before applying the change in the block, Oracle verifies if the block that it is going to be modified is at the right version. The SCN from the block should be the same with the SCN stored in the redo logs. The best option to detect a lost write is to have a media recovery in place, either having a standby database, either performing restore recover on the database on another system. Oracle does not own a function for writing to the disk, and it is relying on a good functionality of the underlying operating system or storage system for performing this action. Lost writes can be caused by just about anything: firmware, operating system, volume manager, NFS, or third-party software defects, faulty disks, disk controllers, faulty memory, or faulty network components. Since lost writes occur in the I/O subsystem, which is not part of the Oracle database code, Oracle cannot detect when it has happened. The lost write is detected during the recovery process when that particular block is modified. Earlier detection of the lost write can be enabled by setting parameter dblostWriteProtect, which was introduced in 11G. By default, the value of this parameter is set to none, which means that the detection mechanism is disabled. As mentioned before, lost write detection is most efficient in DataGuard configuration. In this case, the parameter dblostWriteProtect needs to be set on both primary and standby databases. If it is set to typical on the primary database, the instance logs buffer cache reads for read-write table spaces in the redo log, which is necessary for earlier detection of lost writes. If set to full on primary database, the instance logs reads for both read-only table spaces and read-write table spaces. When the parameter is set to typical or full on the standby database or on the primary database during media recovery, the instance performs lost write detection also for read operation. When the parameter is set to none, either on the primary database or on the standby database, the lost write detection functionality for read operation is disabled. Because of the way the software is designed, lost write detection is implicit in the code, but it is done only when a new change is performed on that particular block that encountered the issue. So, what is the difference when dblostWriteProtect is set? The difference is that when it is set, every select statement will generate a small redo change saying, this block was read and the block contains this SCN. This redo will be propagated and applied on the standby database, allowing it to detect lost write when the block is read. Document ID 1265884.1 says studies have shown that the impact of setting this parameter on the primary database is insignificant. If the dblostWriteProtect initialization parameter is set to either typical or full on both primary and standby databases, then in case of a lost write detection, the error code thrown is no longer Ora 63020. But the error becomes more explicit, saying where the lost write has occurred. When a standby database applies a redo during managed recovery, it reads the corresponding block from disk and compares its SCN with expected SCN from the redo log. If the SCN in the redo log is lower than the SCN of the block on the standby database, a lost write on the primary database is detected and the error reported is Ora 752 recovery detected a lost write of a data block. If the SCN in the redo log is higher than the SCN of the block on the standby database, a lost write of the standby database is detected, and the error throw reported is either Ora 756, either Ora 753, recovery detected a lost write of a data block. When error Ora 63020 is signaled, the best option is to engage immediately the Oracle support for diagnosis. No corrective actions should be taken until it is determined where the lost write has occurred, as the action plan is different for each scenario. Gather all the required information needed for diagnosis and root cause analysis as documented in the note 1265884.1. This error can be seen also on a standalone database where recovery is performed. Let's suppose the following scenario. On 1st of March, we take a backup of our database. On 10th of March, we take the decision to use this backup to duplicate the database on another system. When we recovered the restored database, we encountered Ora 63020. What does this mean and what are our options? The occurrence of the stack recovery error means that somewhere between 1st of March, when we have taken the backup, and 10th of March, when recovery was performed, a lost write happened. Because of the lost write, a particular block hasn't been updated on disk, but the redo generated for this change has the correct information. So, when the same block, which has the lost write, is read during the recovery, it fails to apply the redo because the redo log has different information about the block version. The lost write can happen either on the database source of the redo, either on the database where the recovery is performed. Analyzing the trace files will help identify where the lost write occurred. Possible solutions at this point are either to cancel the recovery and open the database till that point, either allow corruption into the database and recreate the affected objects. Trial recovery can be used to determine how many blocks and data files are affected. Further details about this option can be found under the document Trial Recovery Recover Database Test, document ID 283262.1. This trial recovery occurs only in memory. When the trial recovery encounters a stack recovery or a similar problem, then it makes the data block as a corrupt block in the memory, and this action can allow recovery to proceed. The errors generated during trial recovery can be found in the alert log. After identifying how many blocks are affected and probably the affected objects, the decision can be taken to allow the corruption into the database and further performing the recovery. The affected objects need to be recreated as of now they are corrupted. In order to have a better understanding on how the lost write can occur in a data guard configuration consisting of a primary database and a physical standby database, and how the lost writes are detected by redo apply services, Ana Maria will show you two demos. One, it is for a lost write that occurs in a primary database, and another one for a lost write that occurs in a physical standby database.
Hello everybody. Let's start with the example of how a lost write can occur in the primary database. At database system change number 100, an update operation is performed on the data stored in block 135 of data file 13. Last time the block was changed was at SEN 58. On both primary and standby databases, the header of the block 135 shows that the block's version is SEN 58. Upon the DML operation, the block is read from disk into the database buffer cache. The change to be made is written in the alert log, and it includes the version of the block to be changed, 58, the SEN when the change happens, in this case 100, and what changes are to be performed, in this case update operation. In the buffer cache, the block is updated and the SEN stored in the block's header is modified to the value at which the DML is performed, in this case 100. Checkpoint is performed and the now dirty block 135 needs to be written to disk. The database writer processes send the I/O request to the OS to write the dirty blocks to disk. The I/O acknowledges writing the block to disk, and Oracle generates a block written record at SEN 105. However, despite the fact the I/O acknowledged the operation, the new version of the block was actually not written to disk. On the persistent memory, block 135 of data file 13 is still at the old version, and the update operation performed on the database is lost. No errors are generated by Oracle as the I/O acknowledgement was received. Let's see now what happens on the standby side. The redo log generated earlier at SEN 100 is sent from primary to standby database. Recovery process tries to apply the redo, and block 135 is read from disk into the buffer cache. In the buffer cache, the block is updated while the change is applied, and the SEN stored in the block's header is modified to the value at which the DML is performed, in this case 100. Buffer cache is flushed to disk, and the database writer processes send the I/O request further. On the standby database, the I/O operation is successful, and the block on disk has SEN 100. Let's see now how the lost write is detected. After a while, on the primary database, at system change number 2000, a delete operation is performed on a row stored in block 135 of data file 13. The block is read from disk into the buffer cache, and another redo information is generated. This redo log includes the version of the block to be changed, in this case SEN 58, the SEN when the change happens, 2000, and what changes are to be performed, the delete operation. In the buffer cache, the block is updated, and the SEN stored in the block's header is modified to the value at which the DML is performed, 2000. After a checkpoint, the dirty block 135 is written to disk. The I/O operation is successful on the primary database, and on disk, block 135 has now the SEN 2000. On the standby database, the redo generated on primary by the DML operation at SEN 2000 is read by redo apply services from the redo logs received. Block 135 is read from disk into the buffer cache. In the redo information, the SEN of the block to be changed is 58. This value is compared with the SEN in the block's header in the buffer cache, which is 100. Since these two SENs do not match, the stack recovery error is thrown. To determine that the lost write has occurred on the primary side, the trace files generated need to be analyzed. In the standby trace files, we can find the details of the change supposed to be applied at the time when the recovery got stuck. In order to determine the database where the lost write has occurred, we need to compare the values of SEN stored in the block's header from the buffer cache and SEN of the block on which the DML operation was performed according to the information from redo. The expectation is that these values are equal. If the SEN value from the redo is lower than the one found in the standby database, we can conclude that on the primary database, the change was made on an older version of the block than the one existing in the standby database. If a lost write occurs on the primary side, the information modified at that particular SCN cannot be found in the primary database. However, this information is available at the standby database as the recovery process applied that particular redo and the block was updated on disk. What actions should be taken in this case? Well, this will depend on how important the affected objects are. If the issue is with an index, perhaps just recreate the index in the primary database. If the issue is with a not very important table, recreating the table in the primary database might be an option. If the affected object is a critical segment, first option to be considered is to activate standby database, and if this action is not feasible, the second option is to recreate the objects affected on the primary database. Copying the data file from primary to standby should not be taken into consideration, as it will propagate the corruption also to the standby side. If the data integrity is extremely important, a failover to the standby database can be performed immediately, either using SQL plus command activate standby, either in case data guard configuration is managed by broker, bgmgrl command failover to standby. We need to be aware that activating the standby database might imply data loss. As the recovery process was stuck, the standby is not in sync with the primary. The changes made on the primary database after the moment the standby detected the lost write will not be found on the activated standby. If a long time has passed between the moment when the recovery was reported and the moment the lost write was determined to be in the primary database, then activating the standby may cause an unacceptable data loss. In this case, the affected objects can be recreated on the primary side, and the allow corruption clause on the standby side can permit recovery to continue. The standby alert log contains information about the affected blocks, file number and block number, and in certain circumstances might also report the data object ID. This information can be used to identify on the primary database the objects affected. If feasible, the objects can be dropped and recreated on the primary database. Once the objects have been recreated on the primary side, the recovery on the standby database can be started using the allow corruption clause. If lost write protection is set on the standby database, it should be disabled temporarily before running the recover command. Once the alert log indicates the block have been marked corrupt, stop automatic recovery and restart manage recovery on the standby database. If lost write protection was disabled, it can now be enabled again. Let's see now an example of how a lost write can occur in a physical standby database or on a database where recovery is performed. We will consider the same starting point as in the previous example. A database system change number 100, an update operation is performed on the data stored in block 135 of data file 13. Last time the block was changed was at SCN 58. On both primary and standby databases, the block's header shows that the version of the block is SCN 58. The block is read from disk into the buffer cache. The redo is generated and it includes the version of the block to be changed, SCN 58, the SCN when the change happens, SCN 100, and what changes are performed, the update operation. In the buffer cache, the block is updated and the SCN stored in the block's header is modified to the value at which the DML is performed, in this case 100. Buffer cache is flushed to disk and the new version of the block is written into the persistent memory of the primary database. The I/O acknowledges writing the block to disk and Oracle generates a block written record at SCN 105. The redo log containing the change generated earlier at SCN 100 is sent from primary to standby. The recovery process tries to apply the redo and block 135 is read from disk into the buffer cache. In the buffer cache, the block is updated while the change is applied, and the SCN stored in the block's header is modified to the value at which DML is performed, in this case 100. The buffer cache is flushed to disk, and the database writer process sends the IO request. The IO operation does not actually happen. On disk, block 135 remains at the old version, and the block's header contains SCN58. Again, no error is generated by Oracle as the acknowledgement of the IO operation was received. We observe that on the primary and standby data file, there are different versions of block 135 on disk. How is the lost write detected in this case? After a while, at system change number 2000, on the primary database, another DML operation is performed on the data stored in block 135 of data file 13. Block 135 is read from disk into the buffer cache, and another redo information is generated. This redo includes the version of the block to be changed, SCN 100, the SCN when the change happens, SCN 2000, and what changes are to be performed, the delete operation. In the buffer cache, the block is updated and the SCN stored in the block's header is modified to the value at which the DML is performed, 2000. After a checkpoint, the dirty block 135 will be written to disk. The IO operation is successful, and on disk, block 135 has the SCN 2000. The redo is sent at the standby database, and it is picked up by the recovery process. Block 135 is read from disk into the buffer cache to be modified. In the redo log, the SCN of the block to be changed is 100. This value is compared with the SCN of the block's header in the buffer cache, which is 58. Since these two SCNs do not match, error Ora 63020 is thrown. In the standby trace file, we can find the details of the change supposed to be applied at the time when the recovery got stuck. In order to determine the database where the lost write has occurred, we need to compare the values of SCN stored in the block's header from the buffer cache and SCN of the block on which the DML operation was performed according to the redo log. The expectation is that these values are equal. If the SCN value from the redo is bigger than the one found in the standby database, we can conclude that the lost write has occurred on the standby database. Another indication of this fact is message kcox future, change in future of block. When this message is encountered in the trace files generated for stack recovery error, then it is most likely that the lost write has happened on the standby database or that the redo chain is broken. If the lost write has occurred on the standby side, the information is missing in the standby database. The primary database has no data loss in this case. In order to bring the affected blocks to the correct version on the standby database as well, we can copy the data file to which the blocks belong to from primary database. The standby alert log contains information about the affected blocks, file number and block number. Before copying the data files from primary side, it is recommended to make sure that these data files are not affected by any other type of corruption. Even if the lost write has occurred on the standby database, the data files from primary side could have been affected by other types of corruption undetected so far, and this step is just a double check. Armand validate command or dbverify utility can be used for checking this. If the source data files do not present any physical or logical corruption, a backup of those can be taken from primary and restored to the standby database. Let's move on to the best practices section to see how the impact of this type of issue can be minimized. As Oracle does not own a function for writing to disk, there are no solutions at this point to prevent the lost writes. But there are a few settings that can help for an earlier detection of lost writes. As lost writes are mainly detected at recovery, the best option to detect them is to have a data guard configuration with a physical standby in place. Setting the parameter db-lost-write-protect on both primary and standby databases will detect lost writes also at reading operations. If the data guard configuration is broker managed, then property primary lost write action can be used to change the behavior of the primary database when a lost write is detected. Using ASM mirroring with normal redundancy might help in the case of a lost write, as chances are the write to be successful on the mirror side. Also, having a good backup strategy might be useful when combined with recovery tests, as lost writes are detected at recovery. Starting with Oracle Database 12c Release 2, there is an available procedure, dbms_dbcomp.dbcomp, that can detect lost writes by comparing the blocks of the primary database with the corresponding blocks of the standby database. Oracle Database 12c Release 2 introduces also a new feature called Shadow Lost Write Protection that enables lost write detection to occur at the database without requiring an Oracle Data Guard configuration. The broker configuration property mentioned earlier is available starting with Oracle Database 11g Release 2 and determines what action is taken if a standby database detects that a lost write has occurred at the primary database. The default value is continue, in which case no actions are taken at the primary database. If the property is set to shut down and the standby database detects that a lost write has occurred at the primary database, then fast start failover is disabled and the primary database performs a shutdown abort. When the property is set to failover and fast start failover is enabled in maximum performance mode and configuration is within the acceptable limits specified for the fast start failover log limit property, then the observer initiates a failover. When the property is set to force failover and fast start failover is enabled in either maximum performance or maximum availability mode, then the observer initiates a failover. This option results in a data loss failover. For both the failover and force failover options, if fast start failover is disabled, then no failover occurs, but the primary is shut down. This property requires db-lost-write-protect database parameter to be set to typical or full. Shadow lost write protection provides fast detection and immediate response to a lost write. Using shadow lost write protection can minimize data loss and the time required to repair the database where the lost write has occurred. To use shadow lost write protection, you must enable it for the database and create one or more shadow table spaces. A shadow table space is a special purpose big file table space that contains only system change numbers for tracked data files. When a tracked data block is read from disk, shadow lost write protection can detect a lost write by comparing the SCN for the block in the shadow table space with the SCN of the most recent write in the block being read. If the shadow entry has an SCN greater than the data block being read, then a lost write has occurred. When a lost write is detected, an error is returned. This PLS-SQL procedure is available in Oracle Database 12c Release 2 and can be used to detect lost writes or other inconsistencies by comparing the same data blocks on the primary and physical standby databases. The procedure can be executed at any time as long as the databases are at least mounted, and it does not require the db-lost-write-protect parameter to be enabled. The blocks on the primary database can be compared to the database blocks of one or more physical standby databases. Logical standby databases, parsing instances, and cascaded standbys cannot be target database for the dbms dbcomp.dbcomp procedure. This procedure can be executed either from primary database, in which case the data files specified when running the procedures are compared to the corresponding data files from all physical standbys in the configuration, either from standby database, in which case the data files specified are compared only between the primary and the respective standby. The output generated by the procedure will show the number of blocks affected by lost writes, the block's details, and if the lost write has occurred on primary or on the standby database. In this example, the procedure was executed on the primary database and the lost write was found to have occurred on the block 135 of data file 13 on the primary side. Today we have covered understanding the error Ora 63020, understanding lost writes, determining where the lost write has occurred, what actions can be taken depending on each situation, and how to earlier detect lost writes. Here is a listing of articles you may find helpful. The second item listed, resolving Ora 752 or Ora 63020 during standby recovery, is particularly helpful to understand what actions need to be taken in case the database is reporting a lost write. Over to you, Marius.
Thank you, Ana Maria. We are going to open the Q&A in just a moment. Please use the Q&A panel or the phone line to ask any questions. You can send the questions via Q&A panel on the WebEx screen or press *1 if dialed in on the phone. While we pause to collect your questions, I'd like to share some helpful information. We'd like to invite you to stay connected with Oracle support via our various social media channels listed here. We have the Oracle database communities where you can post your questions and converse with subject matter experts and peers from other companies. My Oracle support blogs where you can keep informed about our priority announcements. Let's quickly cover each of the elements and their supporting icons that you will see throughout your learning experience working on my Oracle support portal and cloud support portal. Online help documentation can be found from the help link on most pages on the portal pages. With the Oracle Support Essentials webcast, you'll learn how to best use the support portals, my Oracle Support and Cloud Support portal, and provides tips and tricks on how to effectively work with Oracle Support. Oracle Support video series provides you with a repository of detailed training videos. Oracle Support Accreditation delivers a targeted learning experience to increase your expertise with support portal core function and product-based support tools. As an Oracle Premier Support customer, you have access to a wealth of powerful resources to help you proactively manage your business. Use document 432.1 to get proactive and prevent issues and to contact the team responsible for proactive programs. You can also get a complete view of upcoming events with the Get Proactive Events calendar. The Proactive Support team sponsors a wealth of proactive support activities, including advisor webcasts like this one. You can get a complete view of upcoming events and activities with the Get Proactive Events calendar shown here. This calendar is automatically updated to include currently scheduled advisor webcast, user group session, most essential trainings. You can filter the visible activities according to the Oracle software products most relevant to you. Look at documentation for more details, but you can also set calendar to display based on your time zone, and all of the event start times will update accordingly. Take advantage of the calendar to find sessions that will help you better utilize your products. Now we are going to open it up for questions. Operator?
I am showing we have no phone line questions at this time.
Thank you. We have a written question. If we have a standalone database with lost writes, will analyze table command report it?
It depends. Sometimes the lost write remains undetected on a standalone database as the block is healthy, just contains all the information. If the lost write happens on a table with indexes, analyzing the table can report Ora 1499 table index cross-reference failure, but only if the lost write has not affected simultaneously the table and its indexes. If the table does not have any index, depending on the situation, Ora 8103, object no longer exists, can be reported, or Ora 1410, invalid row ID. But also there is the possibility that no error is reported. Having no error reported by analyzed table is no guarantee that no lost write has affected the blocks. Best option is to have media recovery process in place, as lost writes are detected when performing recovery.
Thank you. We have a question. If the second change, DML, hasn't happened for a long time on primary and with lost write on primary, will the users be reading the wrong information from the corrupt block because of lost write?
Yes.
Okay, thank you. Another written question. What errors might be reported when the lost write is on a standalone database?
Well, most of the times no error is reported because the block is healthy, just contains all information. But sometimes putting together all the pieces of the puzzle can be reported different type of errors, like object no longer exists, Ora 8103, index key not found, Ora 8102, table index cross-reference failure, Ora 1499, or snapshot too old, Ora 1555, or invalid row ID, Ora 1410, or different Ora 600 internal errors.
Thank you. Another written question. Can we recover the lost write block alone from standby to primary and the other way around from primary to standby instead of restoring the entire data file?
For the moment, no, there isn't a procedure to do so.
Okay,
We have,
yes, please go ahead, sorry.
Yes, I was saying that for the moment, the solution is to copy a backup of the data file and restore it at the standby database.
Thank you. Another written question. What will happen if there is a lost write and also a deadlock occurring at the same time?
We will need to perform some further investigation for this situation and provide an elaborate response.
We will. Does logical standby reports error Ora 63020?
No, it does not, because on the logical standby, the SQL apply transforms the data in the redo log files into SQL statements and executes them on the database. The block structures in a logical standby database are different than the ones on the primary, so the lost write is not detected.
Thank you. Another written question would be, if the lost write was on standby, can roll forward with incremental backup be used?
Yes, it can. If managed recovery process stops due to a lost write detect on the primary database, on the standby database, I'm sorry, the procedure to roll forward the standby using incremental backup from this can also be used instead of copying the data file from primary to standby, and it will also bring the standby back in sync with the primary.
Thank you. Another written question that we have. What actions need to be performed if the lost write is reported after a switchover?
If the lost write is reported after a switchover, However, the course of action would be the same as explained in the presentation. If the lost write has occurred on the former standby database, after the switchover, the information will be missing from the current primary. So the actions are either to recreate the objects, either to activate the standby. Or if the lost write has occurred on the former primary database, after the switchover, the information will be missing from the current standby database. So in this case, the action is to copy the affected data file from primary database to standby.
Thank you. Operator, are there any phone line questions?
No, sir, we have no questions at this time.
Thank you. We have another written question. Can the lost write be mistakenly reported by recovery?
Yes, there are some cases when the error Ora 752 is raised in a data guard configuration, even though there was no lost write for that block. If we suspect that the lost write reported is fake, we can set DB lost write protect parameter to none and restart manage recovery. If the lost write has actually happened, recovery will stop with error Ora 63020.
Thank you. Another written question. Trial recovery discovers all lost writes?
It may not, because this depends on the buffer cache size. During test recovery, the data files are read into the buffer cache. Since the recovery is applied only into the buffer cache, dirty blocks are not flushed to disk, and there may not be enough memory to read all the blocks needed for recovery.
Thank you. Another written question that we have at this moment. If the lost write has occurred on primary, can we copy the data file from primary database to standby?
It would not be recommended, because in case the lost write has occurred on primary, if we copy the data file from primary to standby, we will bring the blocks from the standby database to the same older version as on the primary. So we will lose the information from the standby database as well. So no, the answer is no.
Thank you. If there are no further phone line questions, there is one more written question that I have. Can we use backups to repair a database affected by the lost writes?
We can do that in the case we have a valid level 0 backup taken before the lost write has occurred, and we have available all the archives generated from the moment backup was taken until now. In this case, we can restore the backup and perform recovery until current archive. If the recovery operation is successful, we should have a database that contains the information that were lost.
Thank you. That concludes our Q&A portion of the session. Thank you for a wonderful session and answering the questions. I'd like to go over how you can locate the recording and Q&A from the session today. Doc ID 740966.1 is your starting place to find out about upcoming webcasts or get the recording, PDF, or continue the discussion links for all webcasts. From the drop-down on this page, you can select your area of interest. Here, we'll select Database. You can also go directly to the Oracle Database document. You will be able to see all upcoming webcasts on the Current Schedule tab. For today's event, you can select Archive 2018 tab. You can click on Calling heading to sort. Hover on webcast title for more information. If you have any questions on a webcast, ask questions via the question link. Recording available within 48 hours. PDF from today's session will also be posted there. The link you see here is for the Understanding and Troubleshooting Ora 63020 webcast Continue the Discussion thread. The Q&A from today's webcast will be posted to this thread, as well as responses to questions that we do not get to during the webcast. Please use this thread for any follow-up questions you have related to today's topic. To easily keep track of updates to the thread, you can use the following link in the upper right to add this thread to one of your MOSE streams. Selecting the activity link from the top right portion of the screen will take you to your inbox and list all streams you have created. You can also choose to bookmark or like a particular thread. We hope you found the webcast valuable. Please take a moment to share your feedback on this presentation and the webcast program via the survey that will display when you exit today's event. Let us know what topics you'd like to see covered in future webcasts. Thanks to Cristina and Ana Maria for understanding and troubleshooting Ora 600 3020 presentation, and to Cristina, Angela, and Silvio for joining during the Q&A. Thank you to each of you for taking time out of your day to join us today. We know you have many demands on your time and appreciate you choosing to spend some of it with us. This concludes our webcast today. Enjoy the remainder